So in the next presentation, Phil Rosenfeld will take the guesswork out of Pachychoroid.
Thank
Good
you.
luck.
So I do have relevant financial disclosures. I have a research and consulting relationship with Carl Zeiss Meditech. So on behalf of the OCT research team at the Bascom Palmer Eye Institute and University of Washington, Seattle, I'd like to share with you the work we've been doing to take the guesswork out of Pachychoroid. These are my colleagues at Bascom Palmer that are really responsible for this work, along with Ricky Wong's group at the University of Washington, Seattle, that developed the algorithms, and the scientists and engineers at the OCT manufacturer. So here's the important take-home message. Choroidal thickness depends on location within the posterior pole and decreases with age and axial length. Choroidal vascularity index is independent of location and age. It may be a more useful measure for disease, and the definition of pachychoroid-related diseases really should depend on measurements exceeding the 95% normal limit. So we're going to talk about the choroidal layer, which is this highly vascular layer between the RPE-Brooks membrane complex and the sclera, and it has both vascular and non-vascular components. Now, routine spectral domain OCT does an excellent job of showing the vascular nature of the choroid, but oftentimes we couldn't image the posterior scleral boundary with the choroid. Rick Spade developed enhanced depth imaging, which opened up a whole new world of measuring choroidal thickness. And numerous reports have discussed variables that affect central choroidal thickness. We know that it decreases with increasing age and axial length. We know that the measurements depend on location within the posterior pole, and that increased central choroidal thickness has been associated with a range of conditions known as the pachychoroid disease spectrum. And here are these diseases. Most notably, we're all familiar with central serous chorioretinopathy and a thickened choroid. But what is a pachychoroid? Well, it's an abnormally thick choroid, and historically, this has not been defined based on 95% normal limits of choroidal thickness within a given population. So there are several questions. One, is pachychoroid defined by just the central macula or the area outside the macula? And are pachychoroid-related diseases defined solely by choroidal thickness at a specific location, or by the ratio of various choroidal components, the vessels versus the stroma? Now, with the advent of swept source OCT, we no longer need enhanced depth imaging because the longer wavelength has less sensitivity roll off into the choroid, and we get excellent imaging from the vitreous through the choroidal scleral boundary. Not only that, it's a faster scanning rate compared to spectral domain. We can obtain larger images with denser scanning densities. So 12 by 12 and 15 by 9 scans are routine, along with montages of these images. So here's a 12 by 12 OCT angiographic image of the back of the eye. Here are the B scans. And you can see the choroid pretty well from unaveraged B scans. So can we develop an automated algorithm to measure the choroidal thickness? We and other groups have tried, and we've developed semi-automated algorithms, but it wasn't until Ricky Wong's group developed this attenuation correction algorithm that we could routinely segment the posterior choroid scleral interface in an automatic fashion. So here we have attenuation correction, we can segment, and now we have an automated choroidal thickness map that's reliable and reproducible. So what about the choroidal vessels? Well, OCT angiography does a terrible job measuring flow in the larger choroidal vessels. So how can we develop a choroidal vascular map? Well, we borrowed from the work of Sonata and Agrawal, looking at routine B scans and segmenting out the vessels in the area of the choroid by developing what they refer to as a choroidal vascularity index. But here we're looking at the volume of the vessels in the choroid relative to the volume of the choroid. So now we're able to segment the choroid, we're able to segment the vessels, and now we have an automated choroidal vascular map in the back of the eye. And we've gone through an intensive validation protocol, and we've shown that they are pretty much identical. So we developed a normative database of 10 subsubjects from each decade of life, no history of diabetes or uncontrolled hypertension, axial length less than 26, 12 by 12 scans were analyzed of 144 patients and their eyes. And as shown here, and as numerous groups have reported, as you get older, the choroidal thickness decreases with age. So here we have an average 12 by 12 map showing what has also been reported in the past, that the choroid is thickest in the center superiorly and thinnest under the optic nerve. However, now we can report the upper 95% limit for all ages and the lower 95% image. And when you look at each decade of life, you can see the 20s, the 30s, the 40s, 50s, 60s, 70s, and 80s. And as you get older, your choroid's getting thinner. This is the mean choroidal thickness over time. So we've divided it up into 9 sub-regions, and whether you look at the center or the peripheral regions, they all decrease with age. And if you look at the 95% normal limits and you focus on the 5 millimeter circle, you can see the range is enormous. There's huge amount of variability. In fact, in every decade of life, the range is at least 250 microns, and a lot of what's been reported as pachychoroid really doesn't fit the 95% normal limit range. Well, what about the choroidal vascularity index? What's interesting is the choroidal thickness totally depends on the choroidal vessel volume. It's a very highly correlated relationship, so that when you look at the slope of the line or the ratio or the choroidal vascularity index, it's fairly uniform. So this is the average map for all ages. 95% upper limit, lower limit, and with each decade of life, you'd see it's very constant, right? So now, when you look at the center region or the peripheral regions, it's a fairly constant number, and when you look at that 5 millimeter circle, the range is narrow, and it's fairly uniform irrespective of age and location. So choroidal thickness follows the choroidal vascular volume. The thickness and vascular volume are greatest in the center and superior posterior pole, but choroidal vascularity index is constant throughout the posterior pole, and pachychoroid really should be defined based on the 95% normal limits for age, axial length, and location. So this paper's online, available in Ophthalmology Retina. So in summary, choroidal thickness depends on location within the posterior pole, decreases with age and axial length. The choroidal vascularity index is independent of location and age and may be a more useful measure for disease. And the definition of pachychoroid-related diseases really should depend on the measurement of the 95% normal limit. Thank you for your attention.